Hello and welcome back. This is going to be part 10 of this series for the Hare programming language, and this video is going to cover this section in the tutorial on control flow. And really quickly, I will do a complementary fast fetch, and you can see I'm on Debian. Debian was my very first Linux distro ever, probably like 6 or 7 years ago, and I just wanted the stability of it. If you've run Debian, anyone in the Linux world knows how stable it is. I just got kind of tired of the constant updates, to be honest, and I just want a little more stability. I don't do things like, as you can tell, I don't do things like rice my system or anything like that. The basics are fine for me. So, anyways, so go ahead and navigate to this part of the tutorial, and let's go ahead and get started. Okay, so go ahead and copy and paste this program into your text editor, and we will jump over there in a moment. Let's go ahead and get started reading this section. We have used these expressions many times without explanation, but now we'll dive into control statements in depth. We'll begin with statements that select from one or more branches of execution, if and switch. An if statement selects from one or more branches based on the truth of a Boolean expression, such as x is greater than 5. If this statement is true, the corresponding branch is executed. Optionally, you may follow the true branch with an else keyword and another branch, which is executed should the conditional expression turn out to be false. Now, this section here on control flow is probably going to be really straightforward for you. Especially if you have, prior programming experience. So Hare also supports else if expressions, which execute their branch if the previous branch is false and a second condition of their own is met. So that's right here. So we have if and then a Boolean expression. And something to note, integers do not convert to Boolean expressions in Hare, so you cannot use integers like you can in C. In Boolean expressions, it has to actually evaluate to a Boolean. So if this first condition is met, this is the code that executes, right? Then we have else if this condition, and then code that executes, so on and so forth. Again, this should be very straightforward if you have any prior programming experience. An important note is that if expressions, like most Hare expressions, can appear in any expression and can compute a value. The printStock function from this sample code uses this to determine if liter should be written in the plural form by testing if the quantity is not 1, then selecting between an s, so a string suffix, and an empty string. And that's right here. So the way this function works, and again we'll dive into this, is if this condition is true, okay, then it will return this s string, else it will return an empty string. Okay, switch expressions provide a more structured approach to branching. Based on a single value, the switch value, one of several cases, is selected. The switch value can be any primitive type, such as integers or rune, as well as strings and enum values. The color_str function in this sample uses a switch expression to select a different branch based on the value of the color parameter, then returns a string representing that value. So that's right here. And this is wrapped inside of a function. So we're passing in color, which is an enum right here, okay? And basically what we're doing is we're stringifying this, okay? And we're saying, okay, case, and then we match on the value, okay? Because this is a type, okay, or a value, okay? Enum is the type. So we're saying color red, these are namespaced, under color. Now, enums and Hare, I'm honestly still trying to figure them out a little bit. Um, in the language spec, they're their own type. Okay, an enum type is its own type. Now, you can cast them to an integer, but they are not represented in the type system as an integer, like you would see in C. Okay, and so we're using this case statement here, and if the color is red under the enum, we're returning this string. You can see this function returns a string. So basically what this does is switches on this value, the enum value, and then returns a string based on that value. Okay? Okay, note that switch expressions are required to be exhaustive, which means that every possible value of the switch value should have a corresponding branch. If you do not want to handle every possibility individually, you can add a default branch by omitting the value, and then this is the syntax for that. This branch will be executed should no more specific branch suffice. This is also possible with match cases that omit the match type, so you can also use this for pattern matching as well. Okay, and so let's look at this program and see what's happening. So we're using this is the first introduction to enums, enum, tomato, tomato. So we're creating an enum, and these are the values here. And what we're doing is inside of our main function, we are creating an array named stock, and these are tuples. Okay, tuple, tuple, tomato, tomato. So these are tuples of an enum and an integer. Okay, and that gets passed in as this item variable to our print stock function. Okay, and then here on this line, we are destructuring this tuple in order to grab each one of its values. So the enum is going to be color, and then the integer is going to be amount. Okay, and then what we're doing is we're calling the print format line function, and from our stringify function, from our color str function, we're calling print stock here. So this is a print stock function. This gets passed in, and the color str function, we're calling it right here, okay, and stringifying the enum value. So that's going to go here, and so it's going to say something like red paint, okay, and then it's going to give us the number of liters here. So you see amount, right? After when we destructure this tuple, this is the amount. So it's whatever integer this is here, okay? And then based on that, okay, if amount does not equal 1, we are returning an S to put on the end of this word right here, liter. So if it's more than 1, if it's not 1, so 6 or 4, it's going to print liters in plural, okay? So that's basically what's happening here. Okay, let's go ahead and jump over into the text editor. Okay, so here we are over in the text editor, and we can see this in action. So let's start with this color str function, which is our switch, and we're passing in a color, and you can see we're using the case keyword and stringifying, returning a string based on the enum color that's passed in. Okay, now that's going to be right here. Here's our enum. Okay, so what we're doing here is we're creating an array, and these are tuples of the string, the enum value, and then an integer. Okay, and this is the number of items available, basically. How many are in stock, basically. So within the print stock function, we're passing in, okay, this enum here that we created here, okay, gets passed in as an item variable, and we're destructuring that. That's what this is called. It's called destructuring. We're taking this this tuple value, which is a product type, and we're destructuring it into the first value is going to be color, so that's this, okay? When this gets passed in, color red is going to get passed in as color. It's going to be destructured as color. And then the amount, okay, is going to be is right here, and we are destructuring, when we destructure this tuple, it gets plugged into the amount variable, okay? Then we are calling the print format line function, and for this value here, okay, we're calling this color str function. And what this does is returns a string based on the enum that's passed in. You can see we're passing in the color, which is here, okay? Now amount is just the amount, so that gets plugged in, which is here, and that gets plugged in right here, okay? And then again, if amount does not equal 1, we are returning an S, which means it's plural, so that's right here. Else we are returning an empty string, okay? So let's go ahead and run this. Let me clear my screen. And you can see what's happening. This is just a normal call to a print function. And so this is where our enum gets turned into a string and paint. And then we have a tab character. And then we have the amount. And then leader, you can see when we have more than one, our if expression is returning an S to append onto this word right here. So that's basically how that works. And what we're interested in here is this if expression, okay, and this switch. Okay, so that's mostly what we're concerned with here in this part of the tutorial. And you can see that this is basically like the ternary operator in C. Okay, so this is like a ternary expression. And I can show you some more uses of if after the next section. So hopefully this is pretty straightforward. If you have any questions, please put them in the comments. And let's go ahead and proceed to the next section. Okay, this section is entitled Using Yield. And this is going to cover in a little bit more depth this yield keyword. Okay? So in many of the samples so far, we've seen the use of brackets to denote blocks of expressions which are evaluated one after another. In many languages, these are decorative, but in Hare they have a semantic meaning. These introduce new compound expressions, and like most other expressions, these expressions can compute a result using the yield keyword. The simple example given here is meant to show some simple usages of yield similar to ones we've seen and left unexplained in previous samples. The only clarification we wish to add here is to draw your attention to the bracket characters and clarify that the yield keyword causes the nearest compound expression to stop and to have the result of that expression set to the value provided to yield. So that would be right here as one example, okay? The sample code shown here uses this to cause the value of f to be assigned to the file variable for further use outside of the match expression. This example keeps things simple, but in the field you will probably find yield useful less frequently in situations that are less obvious. Getting values out of match expressions is likely to be the most common use of this feature in your code, but keep yield in your tool belt and you might end up using it to solve other problems every now and then too. So here we are using yield twice. Let's go ahead and look at this example. So what's happening here is this is OSArg, so when we pass in an argument, what this program does is it takes your file and prints its contents to the to standard output, okay? You can see we're passing in standard out here, okay? So it uses OS open to open the command line argument that you pass in. Okay, and since OS open, let's go ahead and look at that. Okay, now you can see it returns an IO file or file system error. Okay, so that again, that's what we're using the match here, and we are if we have a valid file handle, okay, it's going to be placed in this gosh, I'm blanking out now. This variable, excuse me, I kept wanting to say expression. And then what we're saying is we're using the yield keyword to yield this back to our variable here. Okay, this should be very familiar to you since if you followed along with pattern matching. Okay, same thing here. We're using the yield keyword. Now, when you use the yield keyword like this, it evaluates this expression, but it just returns void. Okay, that's basically what's happening here. So this should be pretty straightforward. I don't see a need to really go into any more depth regarding this. Hopefully this is pretty self-explanatory. The yield keyword, we're yielding this value back to our variable here. Now notice we don't have an L value on this, so we're not assigning, we're not like this, right? This is an L value, okay? We're not capturing a value. We're not returning a value to a variable. So here we're just saying yield, and basically it just causes this expression to evaluate, and what actually happens here is it's returning void. Okay. Now I do have the program here. Let's go ahead and run it, and let's pass in our main file, and you can see it prints it to the terminal. Okay, now let's look at let's match on, let's say we'll call this value, and let's match on, and we'll just say hello. Okay. Let and this is going to be it's going to be okay. So this is going to be size. And now what happens if I just say yield? Okay, so I'm just yielding. What this is going to do is this is going to return void. Okay, I'll just say IO error. Okay, what I'm trying to show you is what happens when you just use yield like this, and we're not actually yielding a specific value. Okay, so if I were to yield success, right, if I were to yield this variable, it would return size. Okay, the size of bytes written. Now let's see what happens if I print out our value variable. Okay, because we're just saying yield, which is actually going to yield this back to this value here. Okay, so I'm going to print that out and look and see what happens. I have to import IO. Sorry about that. Okay, let me clear my screen. And you can see it prints, and when we print this value, it's void. Okay, so this is a value of a type. So okay, so it's a void value, and so that's what actually happens when you just use this yield keyword like this. Okay, so to return to this example, that's what happens in this scenario here. It's just evaluating to a value of void. Okay, and we don't need this. We don't need to really use this size variable unless you kind of wanted to check it with an assert statement. Again, you could do that. But I just wanted to show you what happens when you use yield by itself instead of like this to yield an actual. Here we're yielding a value of IO file, which is the file handle, and we're yielding it back to here. So that is using the yield keyword. Let's go ahead and move on to the next section. Okay, so moving on to this portion, this is the section on for loops. And go ahead and copy and paste this into your text editor, and we will jump over there in a second. So all loops in Hare are written with the for keyword, which allows some logic to repeat so long as a condition is met. The syntax is for, binding, condition, afterthought. So this will be very similar to pretty much any looping construct in C or maybe Java, pretty much any sort of procedural language. And you can see that the for loop is the only looping construct in Hare, so there's no while loops or do whiles or things like that. So again, Hare is very simple. So the binding allows you to declare and initialize a variable which only exists within the loop. So again, that's here. Now in this example, the binding is not actually in the loop, so we're accessing it here. The condition determines when the loop terminates. It's evaluated at the start of each loop iteration and will terminate the loop if false. So the afterthought runs after each iteration and is a convenient place to update the variables used within the loop condition. So the binding and the afterthought may be omitted, such as in this code sample, which omits the binding, allowing us to access the loop item I outside of the loop. So that's right here. A loop which never terminates may be written like so. So it's just for true, and this is a infinite loop. Now, one thing that you'll notice here is this syntax here for the afterthought. You'll notice the syntax that's being used. So there is no plus plus I or I plus plus. To me, I wish there were. I often mess this syntax up for some reason. It's just kind of the way my mind works. I often write I plus equals I. I don't know why. I do. And the Hare compiler won't detect an infinite loop. So I don't know. I just don't like this construction here for looping, because generally when you write a loop, you're normally incrementing just by one anyways. So let's go ahead and jump over into the text editor and look at this. So here's the program, and we just have an array of strings here, and we're going to loop through them, and if the string is Hare, then we're breaking out of this loop and printing the index that it's at. So let's go ahead and run this quick, and then I'll jump back in here and explain a couple of things, okay? And you can see Hare is at index 2. Okay, so again, arrays start at index 0, so it's technically the third element. Now, if you notice, we are declaring this before the loop, so we can access this afterwards. What we could do is we could move this inside of the loop. Okay, so this would be a traditional loop. So you would say you have to declare the variable, and this is the way that it would look. This is pretty much the exact same thing, except now, because this is only within the loop, you can access this. We would get an error here, okay? But this is the way a traditional for loop looks in Hare. So let's maybe change this, okay? And instead of doing something like that, let's just print each item, okay? So we'll say, we'll say, what is it? Items, and then the index. Okay. So now let's go ahead. Now we might get an error here, and I'll explain why. Okay, so we don't, but I will show you something interesting about for loops in Hare. So that prints out just fine. You can see that that is basically this is a traditional. This is just as straightforward as you can get with a loop in Hare. Okay, and we're using the built-in len function on our items array here. Okay, so that way we don't read out of bounds. And we're just printing each item here. Now, the thing about a for loop in here is this right here, your let construct, okay, your condition is actually, you can see the suffix here of z. That's a type suffix, and that just means size. Okay, so this is the same thing as saying if we were to explicitly annotate this variable, this would be of type size. Okay, so that's very important to understand when it comes to Hare. So you can see it's specifically annotated. I've removed the suffix here. Now let me go ahead and run this program again. And let me clear my screen. And you can see that it runs just fine. Now, let me explain to you why this is important, okay? It's because, normally when you normally something that a for loop is generally used for is to say like initialize array elements. Okay, so let me show you what happens when we try to do that. So let me just remove this and let's make a loop. Okay, so we'll say items, and let's annotate it with a specific size of type int. Okay, and let's use array initializer syntax and just zero value every element so far. Now here, let's go ahead and make our loop to actually initialize every element of this array. And I'll show you what's going to happen. Okay, so again, it's for let I equal, and generally, this is what you'll see. That's idiomatic Hare. Okay, idiomatic Hare uses this type suffix of z instead of size equals 0. Sorry, this is a different keyboard. Some of the layout's a little strange, actually. So, but that's what it is. But idiomatic Hare is just this right here. Okay. Now we can say while I is less than the len of items, I plus equals 1. See, what I always wind up doing here is this right here. For some reason, I don't know why. It's just, we all have little quirks and things. So this is the proper way to construct a loop, right? Now, let me show you what happens if we try and use our looping variable to actually initialize each element of our array. So we'll say items, and then I equals I, right? That's what you would see. And then what we'll do is just print each item. Now, since this is type size, okay, but if you're going to have an array of let's say numbers, it's usually going to be an integer or an unsigned integer. Okay, so let me show you what's going to happen when you try and do this. Okay, and you can see that the r value, so this is an r value of type size, is not assignable to an L value of type int. So that's what our array members are. They are our array. The subtype of the array is integer. So if you wanted to actually use um, a for loop to initialize an array like this, you you would have to cast this. So you see here's a cast. I'm casting our I variable, which is of type size, to an integer. Okay, so and then we're going to print each item right after it's initialized. Okay, and you can see it prints each item of our array just fine. Okay, because what we're doing is we're casting it. Okay, now let's say we have unsigned integer, it would just be the same thing. Okay, so whatever it is, you're just going to cast your size type, your conditional variable for the loop. You're just going to cast it to whatever type that you need to initialize your array. So let's go ahead and run this. And you can see same exact thing. Now, let me show you what happens if, okay, let me change this to an integer, and same thing here. We'll just keep that cast. Now, let me show you what happens if I remove this z. Okay, because by default, the numeric type, the the integer type is int. Okay, which is actually it's guaranteed to be at least a 32-bit signed integer. Now, that's as opposed to on some architectures maybe it would be 64, but I can't think of a reason why that might be the case. Maybe some type of compiler implementation details on a certain architecture, or if, maybe if someone decides to. Hare has a spec, so this is based on the spec. Okay, so the point I'm trying to make is by default the integral type is int, which is guaranteed to be at least a 32-bit integer, but it is actually not type I32, right? So you would have type I32. That does not equal type I32 does not equal an integer, even though on the same architecture they may be a 32-bit integer. Okay, so that's important to understand. Now, the point that I'm trying to make is watch what happens when I try to run this loop with our conditional variable just being an integer. So int, that it's this type right here. Okay, it's type int. Okay, watch what, and I actually wouldn't even have to cast this technically. So um, let me just remove that to keep things simple. And you can see cannot promote int in size. So the problem here is with this variable. So loops in here again. A for loop is the only looping construct, and it requires an integer of type size in order to initialize it. So that's the basics of a for loop. Hopefully that's clear. Let me know if you have any questions down in the comments. And let's go ahead and move on to this section on for each loops. Okay, so really quick, sorry, I wanted to show you something that I meant to point out. Um, Now this, if you'll notice, this string is written with backticks, so this would be like a raw string. Okay, so in Python, you would have like, this right here. And this is just a raw string because we're quoting Hare here. What we could do is we could say, so it's print format line. If we wanted to create a string, we could just escape this. This might be, you're probably familiar with this already, but I just wanted to show it to you. So we could say Hare, and then let's escape our other string. Is that index, and then it would be I. Okay. So this is just it's a backtick string, and it's because we have quotes inside of it here. So if you wanted to escape this, it would look like this, just like in C, just like in pretty much any other language. So let me go ahead and run this. And you can see it's the exact same thing. But I did want to point that out. I meant to. And so this is a raw string, okay? And that's because we're quoting right here. So anyway, so now let's go ahead and move on to the next section. Okay, so here is the next section on for each loops. Now you might have seen these in Python or some other languages. This is just really nice syntactic sugar that you can use um, for looping. Now I'll go ahead and read each section, but when I jump over into the text editor, I'm actually going to treat these separately so that we kind of don't get overwhelmed. Um, so in addition to the for loops described above, there are also for each loops which make common patterns a lot simpler. These have no condition or afterthought, just a binding. There are three forms of for each loops in Hare: for each value, for each pointer, and for each iterator. The first for each loop, which is for each value, iterates over every element of the items array by value. So what this means is we are making a copy of the item. So just like so there's value semantics and reference semantics, okay, in most programming languages. And that just means that we are just like when you pass a variable to a function, unless you pass a pointer or a reference to it, you are passing that item by value. So that's what the for each value loop is. You're creating a copy of it. So each element is copied to the binding. This is good for small size values or if you don't want to mutate the slice or array directly. So let's go ahead and jump over in the text editor. I have the example here. And so we just have our array, which is constant, and it's just a couple of strings, right? Apple, banana, carrot. And what we're doing, so here's the syntax for that, right? Let item, and I just say of items, but it's two dots. And then you enter the loop and you access each element with this variable here, okay? So we're just printing each item of our array. Let's go ahead and print this out and see what happens. And you can see it just prints the element of our array. Now again, these are just local copies. So this is a value loop, right? We have a value loop and a reference loop. So we're just creating a local copy of each item, and this would be good if copying doesn't take up too much overhead. But if you had a collection where you didn't want to make a copy, say it was too large, you would want to use a reference, which let's go ahead and look at that. Okay, the second for each loop iterates over every element of the items array by reference. Here, only a pointer to each element is assigned. This is useful if you want to mutate the array slice itself or want to avoid copies because the values are too big. The example prints the pointer to the element and then the element itself. So here's the pointer, and here we are dereferencing our elements, okay? So I have this example over in the text editor. Let's go ahead and jump over there. So this is what you would call a for each reference. Now, this is the syntax right here for that. Notice that we are taking a reference of this. Now again, this variable here is just arbitrary. You could name this whatever you wanted. This has to be the name of whatever collection that you are iterating over. So it would have to be this right here. Okay. Now here we just have a simple string, and the address of our pointer gets put in here, and then we're dereferencing the pointer, so the value gets put in here. So that's going to be whatever our array is. So let's run this, and then I'll come back to this and show you something, okay? Okay, so let's go ahead and run this. And so we're printing out the address in hexadecimal. That's standard Unix or Unix-like. And then here's where we're dereferencing each element of our collection. Okay, so again, this is used if you wanted to mutate an element, right? Or say you had a collection that was too large to copy every item. So let me show you like something that you could do, right? We could say if item pointer equals, let's say, a banana. Okay, then what we're going to do is change this, and let's say mango. Okay, and then um, let's print it. So what's going to happen here is it's going to print apple because we're printing it first, and then or excuse me, apple, banana, and then it's going to print mango because here we are mutating this element of our array because we are using the reference for each loop. Okay, so let's go ahead and run this. And you can see it prints everything just fine like it did, so the address and then the value. But after it prints banana, we are mutating that into mango. So this loop construct now contains apple, mango, carrot. Okay? So that would be so again, with the for each value, we are just mutating you're just mutating a local copy. Once you break out of this loop, the elements of your array still remain the same. This is the reference for each loop, and again, you can actually mutate the elements of your collection by reference. So now let's look at this for each iterator. Okay, in the third for each loop, the initializer of the binding is a special iterator function whose return type is a tagged union, which includes the done type. So that's right here. Here's our iterator, and this is what it's referring to here. So we're returning a tagged union of a string or the done type. Now notice this is this is not necessarily built into the language, at least your algorithm. Okay, you're going to have to hand roll your iterator functions yourself. This function is called each iteration, and its return value is checked. If the return value's type is done, the loop is terminated. Otherwise, the value is assigned, and its type is that of the return type minus done. So that means it's not returning done. Okay, so it's just going to be string. In this case, that would be string. A lot of standard library functions make use of the done type or aliases of it. You can use a for each iterator loop in these cases or create some useful functions yourself. Now you notice that it says, note, it is not possible to use insert, delete, free, and append with the slice being iterated over. It is encouraged to use normal for loops for this use case instead. Okay, so let's go ahead and jump over here into the text editor. And you can see that we just have our array of strings. Now we have a counter here, okay, of type size. And what happens here, here's the syntax for this, and you can see it's the arrow operator. So we say let item, and then we're calling this function. Okay, next, this is our iterator function. Okay, and we're just printing each item. And so what happens here is when we call this function, this variable is counting whether this is equal to the length of our items. Okay, and again, because this is global, we don't have to pass this in. Then we're incrementing it by 1 and then returning items and then the counter minus 1 because we need since we're incrementing it here, we need the element 1 before it. Okay, now you couldn't put this after this because this returns type done, okay, or excuse me, never, and nothing can come after type never because it would be unreachable. Okay, then once we increment this and we call it again, okay, so what happens is this is going to be 0 when it comes in, okay, and it's going to check that, and then it's that's true. So then this code is going to run. It's going to be um, the item counter is going to equal 1, but then we're returning items counter minus 1, so that's the 0th element. Okay, so apple, then once we call this again, right, since this is a global variable, it's going to be passed in as 1, right? Then it goes to 2, and we get the element before it, which is 1, so that's banana. Then it returns that item, okay? Then that happens again, it becomes 3, and then minus 1 we want, so that's this element here. And then once that happens, once items counter gets passed in as 3, which is the length of our items, this is not going to run, and it's going to return type done. Okay, so that's how an iterator function works. Basically, the key to the iterator function is this done type. Okay, and that's how your iterator knows when it's complete. Okay, so let's go ahead and run this, and you can see it just prints each item. But this is great if you add, obviously, this is a very basic collection, right? So that is the iterator function. And you can, again, it says, you can loop over standard library constructs like this as well. Anything that returns type done would be a great candidate for an iterator function. So hopefully that's pretty clear. Let's go ahead and move on to the next part, which is flow control. Okay, so now you should be on this section on flow control. We can use break and continue keywords, the break and continue keywords to manipulate control flow in Hare loops. In the previous sample, we used break to terminate the loop early when encountering a string called Hare. In this sample, we stop that loop iteration and continue with the next iteration. Both break and continue have the result type never. What does that mean? Now, again, in Hare, result just means return. So this is what you'll see in the standard literature is result. So the result value, the result type. So this is just a common feature in most every language. And what's happening here is so we're using for each loop. This is a value, okay? And what's happening here is if our item equals the string Hare, we are skipping this loop iteration and returning to the next one. Okay, so instead of continuing, instead of printing that item, we're skipping that part of this part of the logic, and we're just continuing back to our for loop. So what's going to happen here? It's going to print hello world is cool. So it's going to skip this iteration of the loop essentially. Okay, let's jump over here, and you can see that. So we have a for each loop, and this is by reference. By value. Sorry. And if our item is equal to Hare, we say continue. Sorry, that's kind of noisy out right now. We say continue, and this just skips this iteration of our for loop, which this is the rest of it, and continues back up to here, which is going to place us on this item here. Okay, so let's go ahead and run this. And you can see hello world is cool. So it skips that iteration of the loop. And so that's the continue keyword. It works just like in any other language. Same thing with the break keyword. It will break you out of your loop. So here's your loop. Okay, if we had a break statement here, it would break us out of our loop here. And if we change this continue keyword to break, it would just print these first two elements. Okay, so that's the break and continue keywords. Now, you see it says both break and continue have the result type never. What does that mean? Okay, so this is the never type. Let's go ahead and move on to this part. Okay, so now let's look at the never type. Now, if you're coming from C, then Hare's type system might take a little bit to get used to. So previously we had the done type. This is the never type. And one of the main differences between Hare and C is that Hare is a strongly typed language and C is a weakly typed language. Now, Dennis Ritchie actually said that C is a strongly typed language but weakly enforced. So, of course, there's some nuance there. So, but that's really kind of the main difference. So, Hare's type system is just a little bit different. There are a few constructs within the language that you might have to get used to. And again, Hare is strongly typed. So it has these types to do specific things like the done type and the never type. So some expressions such as return, break, continue, yield, and abort, as well as some function calls such as osExit, can never return any value, either because the program is guaranteed to exit or because control flow continues somewhere else. This is represented within Hare's type system as the never type, a type that can never hold a value. Now, if you would like to read this Wikipedia article, please feel free to. So this is important when you consider that Hare is an expression-oriented language. In the sample here, each branch of our switch expression yields a value, the name of the color, to serve as the result of the switch expression, except for color green, because abort's result type is never. The branch doesn't yield a value at all and is ignored when determining the switch expression's result type. We have taken advantage of this behavior many times throughout the tutorial. For example, in using yield, FMT fatal F returns never, allowing us to only provide a value in one case. So it's referring to this right here. Basically, what we're doing is we are switching on our enum, okay? And if we encounter the color green, we're calling abort, so that returns type never. So the point that it's trying to make here, Hare being an expression-oriented language, since it returns type never, in that case, all of these keywords do. But in this case, that result type is not um, um, it doesn't provide a value. Okay, so let's go ahead and jump over into the text editor. And so what we're doing, we have an enum, and here they all are, namespaced under our enum color, and we're just switching on them. And if we encounter green here, you can see that it calls abort. So I think I have green in here at the moment. I think the original example is blue, so let's do that. And you can see your color is blue. Now, if we were to switch this to green, what's going to happen is it's going to call abort. I mean, that's pretty obvious. The point that this is trying to get across is that abort returns type never, and that because it returns type never, right, this branch doesn't yield a value at all and is ignored when determining the switch expression's result type. So that's really the main key takeaway from this right here. Is this little part. Okay, so that's the never type. Please feel free to read this Wikipedia article about type never. And so again, type never can never hold a value, and it's guaranteed to never return to the caller as well. So that's what all of these keywords indicate. So that is the section on the never type. So this video wraps up the portion of the tutorial on control flow. Please join for the next video. I would like to thank any subscriber and then also just anyone who found this video helpful. So I really appreciate you watching. If you have any questions, please put them below. Or if you have any more specific questions, of course, please feel free to get help on the mailing list. So that should be all for now. I really appreciate all of you. Thank you so much for watching, and have a nice day.